So we're going to look at the action of anti-cancer drugs. Before we do that, we're going to look at what cancer actually is. Now, healthy cells, for example, this is a healthy cell, would replicate like this. Cancer cells tend to replicate much faster. So we have a cancerous cell here, which would replicate much faster than a healthier cell, taking over the body and perhaps giving the body some adverse side effects and symptoms. So one of the ways of controlling cancer is to use a chemical called cisplatin. So cisplatin looks like this. So cisplatin consists of platinum, which is platinum 2+, 2 chloride ligands, and 2 ammonia molecules. The ammonia molecules are coordinately bonded to the platinum, and so are the chlorines, which we know means that both atoms in this covalent bond are from either the nitrogen or the chlorine. Another example of that, or another example of the name, is dative covalent bonds. And this structure we can see here is square planar. And basically it works by bonding to strands of DNA, distorting their shape and preventing the replication of cells. So if I draw some DNA, and this DNA consists of 2 strands, that's one strand, here's another. Now we know that strands of DNA are made of a sequence of nucleotides. Within each nucleotide you can have 4 different bases: G, A, C and T. Now I'm only going to show the guanines, represented here by a letter G. Now when you get a couple of guanines like this, obviously we know that on the corresponding strand of G and A, G always bonds with C, so I'm going to put the C's in there just to show how the 2 molecules of 2 strands of DNA are linked together by these 2 hydrogen bonds, or collection of hydrogen bonds. Now what cisplatin does, these 2 ligands here, these chloride ligands, they come off, and the platinum, instead of bonding to 2 chloride ligands, they bond to the nitrogen on guanine. So it works because the nitrogen atoms on guanine have lone pairs of electrons which can form dative covalent bonds to the platinum. So let's have a look at the structure of guanine. So you can see here I've already edited this sheet to show how guanine here can hydrogen bond to cytosine. So it can't be any of these nitrogens here. It can't be this one, because this one here has got a hydrogen on it, so there's no lone pair on this N. And it turns out that it can't be that one because the sugar will be in the way of it. It's this one here. It's always the nitrogen on guanine which is in the pentagon here with a lone pair of electrons on it. So this lone pair of electrons here can form a coordinate bond to the platinum of cisplatin. And what happens here is what we call a ligand substitution reaction. Just like any ligand substitution reaction, we've substituted 2 ligands, which are 2 groups of on the platinum, with 2 more groups. And here we're just substituting the chloride ligands for some nitrogen on the strand of DNA. And what that does is it stops the DNA from replicating. So we've got DNA, cancerous DNA, and it stops it from replicating, which is great because it means that the cells themselves can't replicate as quick. However, like all drugs, cisplatin has side effects. And the thing is, cisplatin can actually bond to healthy cells as well as cancerous ones. However, cancerous cells are replicating much faster than healthy ones. So the drug has a greater effect on the cancer cell than the normal cell. So cisplatin has side effects. However, it has a greater effect on cancer cells as they replicate faster. However, sometimes though, we do have cells in our body that do actually replicate faster. So if you think of our hair, the cells in our hair follicles they need to replicate quite quickly. So this is why patients who undergo chemotherapy, if they take cisplatin, they might get hair loss. Hair follicles, they replicate quite quickly, you see. However, work is underway to find drugs that can better discriminate between healthy cells and cancer cells. Cisplatin is a one which can stop very fast replicating cancer cells from replicating, but it also has a slight effect on healthy cells as well, particularly ones that replicate a little bit faster than other cells in the body. So work is now going on to make sure that we get drugs which have an effect on cells which replicate fast, but don't have an effect on replicating cells which replicate slowly.